Hi, this is Lori, and this is my homework for the Cogsworth City Kit by Inventor.io. We're on the adventure for day 4. And in this adventure, we're going to be using a new component, a sensor called a photoresistor. And I actually haven't spent much time with photoresistors up till now. And so I did a little bit of digging to try to make sure I understand a little bit better how they work. So I put this slide together. I still have a ways to go. As I've mentioned before, I'm not an electrician or electrical engineer, so I've just been trying to learn electronics and robotics as a hobby in my retirement. So every time I run across a new sensor, I try to look it up, and physics was not my not my best subject when I was in university, so yeah, so I struggle a little bit sometimes. But anyways, it's a type of resistor, as you might imagine, that's dependent on, the resistance level is dependent on the amount of light. And if it's in low light, then this will give more resistance to the circuit, and if it's in high light, the resistance will be lower. And that's because it's made of a material, a semiconductive material that will allow it to work that way. And there's a lot of, if you go out and Google, you'll find a lot more information about semiconductors and how that would work. I thought that was a little too much detail for the video. The other thing that we'll do is we'll use a resistor, a 10K ohm resistor in this circuit. And that one kind of threw me. I was like, why do we need that resistor? And I went down a rabbit hole trying to understand that. But this is my best understanding right now, is we use this resistor, and it can be different voltages. And one of the sites I looked at recommended changing this a little bit and seeing how it affects the measurements you get out of your photoresistor. So I thought that was interesting. But we're creating a voltage divider. And by creating that voltage divider and putting our jumper wire that goes to where we're going to measure it in the pin on the hero board, that allows us to measure the voltage relative to changes in the resistance. And if we didn't have that in, and someday I'm going to sit around with my multimeter and maybe try to convince myself that's how it works, but we wouldn't be able to measure the change in voltage across the photoresistor. We have to have another resistor in there to kind of create, a background on which to measure those changes. So I think that kind of makes sense. I found a nice discussion on this electronic stack exchange. Looks like a lot of electrical engineers and students get on there, and somebody asked exactly the question I had. And there were several answers in there, and I think I read them 2 or 3 times to come up with a statement here. And people have different ways of trying to explain it. But anyways, this is where I got to, and feel like I still need to spend a little more time to really get it up here. But I've got a good start now. So that's what our photoresistor is, and this is what it looks like, the one we'll be putting into our circuit. Well, here we are at the day 4 wiring diagram. And so we still have our LED wired up, and it's wired onto 13. I think I moved it to 12 in my code, just because I didn't want to keep flashing the internal LED too. And then here's our photoresistor connected into the power, and then it goes to that 10K ohm, which connects us to ground, and then we connect this jumper wire to one of the analog pins, because we'll be measuring something different, and we won't just be measuring high and low as we would on these digital pins. We'd be measuring a number between 0 and 1023, and so the analog pins over here allow us to make those kinds of measurements. So that's kind of what this device will give us, is a number between 0 and 1023 when we use the hero board to measure it. All right, so next up is take a look at the code. Here's the code for the day 4 adventure. I did it a little bit differently. In this program, I measured the light level in the room in the void setup loop, so like an initial light level, and then I use the threshold value to determine when the light level had dropped enough to turn on the LED. Otherwise, I left it off. So we'll see how I did that in the code. Set up the photoresistor pin on A0 and the LED pin on 12. Then have a light level variable for the one we'll measure throughout the loop. Then my initial light level that I'll measure the one time at the start. And then the threshold. Now, depending on the room and the lighting in the room, you might have to adjust this. I used 100 and that seemed to work. In the void setup, you'll see I set up the LED pin, and I'll skip over this for a minute, and then I also measure the initial light level. It's the first time I think we've used the serial monitor in one of these lessons. So I'm turning this on, and this is how you start the serial monitor. It's over here, and if you click on it, it will come down here, and it will allow us to write things to the serial monitor so that we can see things. So what I'm going to be writing to the serial monitor is the light level as we go through the loop. So we'll constantly be seeing what is the actual measurement we're getting from the photoresistor. I think that's kind of handy so you can see how the numbers change, whether we have the resistor seeing all the light in the room or whether we cover it. And you can see I have the program right, whether we cover it and see a change. All right, see the light come on. So in the void loop, we'll read the light level, the current light level, and we'll print that to the serial monitor. So we use the serial.print line to print that variable's result into our serial monitor. Then here's where I determine has the light level changed enough to turn on the LED, or otherwise I'll keep it off, and then we'll have a short delay. So it's a very simple program, very similar to the one in the code, but maybe a little bit different. Now, for using the serial monitor, you noticed here I had to say 9600 baud. That's what that stands for. That's the speed of communication. And now you can see here's the light level going by, the program's running. To make this work, it has to say no line ending here, and I have to match it 9600 baud to whatever I use up here to get it started. So you can use other values. You may see people use other values in programs, but 9600 is fine for what we need right now. So the program's running, and we can see that we're reading about 850, 860, a little bit of variability as it goes by, and it's communicating. That's why it's flashing, actually. It's communicating with us. And that's one reason why you don't want to go too fast and why you want to have a little bit of a delay. Probably could have a little more of a delay in here, but this works. And so let's cover up our resistor. And I've got the top, I'm touching the whole top of it, so that's just about as low as I can make it go. And so it'll drop down to, in this case, about 500, a little under 600, right? And then we let it off, it goes on. And I kind of like this because I didn't have to keep adjusting the program the way it was in the lesson. I kind of had to adjust the variables a lot, and this seems to work in a lot of cases, at least in my house. So I kind of like that initial kind of calibration of the light, and then looking for a change in that. Yeah, so that's a fun lesson this time, and I definitely got to learn a little bit more about photoresistors. I hadn't really used them much before, and so I did enjoy working through this lesson. And as always, I want to thank you for watching.